So we did work with our calculator to find patterns with vertical translation. And not a surprise, based on all the transformation work we've done with other functions, that when we add or subtract a number, we are moving it up or down. Now, the only difference with trig function is that the number is written first, and not that that matters. So we know that if it is a negative and it moves down, if it's a positive, it moves up. So you can use a trig graph template if you've printed it, or if you want to go ahead and just write this on notebook paper. Okay, so we're going to go through 4 examples of graphing a trig function and naming all the transformations and comparing it to the parent graph. Okay, we're going to graph 2 cycles as we always have. All right, so let's take a look here. Our first equation is y equals -4 minus 2 cosine x. So I always write out the changes in amplitude, period, vertical translation. If you're using the template, you may see phase shift there, and phase shift is something that we are going to do, and you can guess that's going to be moving it left or right. Okay, so in this equation, we know that the amplitude is 2, the period is 2 pi, there's no change. All right, it's going to be reflected because of the negative. And now what we're now, quote unquote, adding to the equation, or in this case, subtracting, the -4 means it's going to move down 4. Okay, also when I go to graph, remember we want to always include 4 angles in addition to 0 to get a complete graph. So I'm going to take my period and divide by 4, and so my x scale will be pi over 2. So I will be counting by 90s. Okay, so my approach is still the same. If I'm graphing cosine, I'm going to graph 1 cycle on the right, 1 cycle on the left. I'm going to count by 90s, which these are our quadrantals, so we should know those. Pi over 2, pi, 3 pi over 2, 2 pi, and then go to the other side, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. All right, now, yesterday I did one example, or in the previous video, I did one example where I drew the graph without movement and then moved the graph up or down, okay? We're not going to do that now. We are going to go ahead and sketch the graph with the vertical translation. So everything that we do is always based on the x-axis. So now what we're going to do, since this is moved down 4, we're going to draw a new horizontal axis at y equals -4. Now, I know that's the line y equals -4, but we're going to look at this as our new horizontal axis, or x-axis, if you will. All right, so now everything we do is based on this axis. All right, so we know that this is cosine. So cosine, oh boy, did I start that wrong? Nope, I didn't. Sorry, it's just, all right. This point should be down here. I just didn't draw it through. All right, cosine would start at 0a, but this is moved down 2. So we know that it's going to be down here starting at 0, -6, because my amplitude is 2. Something that I've seen in the past is people get confused with amplitude and vertical translation. Once you move your new horizontal axis, you don't need to worry about that anymore. You graph it like you normally would. This is cosine, so I would begin at 2 away, 0, -2. My next angle, I would be here. My next angle, I would be 2 away from the axis. My next angle, I would come back through 0, so to speak, and then here I would be at -6, 2 away. All right, and then coming back, there's 1 cycle, so at my next angle at -pi over 2, I'm on my axes. My next angle at -pi, I am 2 away from my axes, back on my axes, 2 away. So I can see that if I was talking about domain and range on this, my domain, of course, is all reals. And my range would be what? It would be everything between -6 and -2. Okay, now Also, I just sketched in a parent graph for you to see why this is vertically stretched. It's twice as tall. We've already said it's reflected, and it's moved down 4. Okay, let's do another one. Let's graph y equals 3 plus 4 sine of 2x. All right, so I'm going to write out my amplitude, my period, decide my x scale, vertical translation. All right, again, if you're using the graph template that was in your packet or attached, it may have phase shift. We haven't done anything with phase shift, so leave that blank. Okay, so if you want to, disregard the vertical translation at first, and then you can deal with that. So my amplitude is 4. My period is 2 pi divided by 2, which is pi. So my x scale, I'm going to take pi divided by 4. My x scale is pi over 4. I'm going to be counting by 45 degrees on the x-axis. Now, my graph will be moved up 3. Okay, so how do I approach this? Well, first of all, I'm going to graph 2 cycles. I'm going to graph 1 cycle on the positive side, 1 cycle on the negative side. Could I continue and graph another cycle and not go to the negative side? I could. I just find that it's probably, quite frankly, easiest to get 2 cycles in, one on the positive side, 1 on the negative side. Okay, so first of all, I'm going to label my angles. Here's 45, pi over 4, 90, pi over 2. That's a positive. 3 pi over 4 pi. And again, if you get mixed up with your angles, you're counting by 45s. All right, but this has to be in radians because if you put these on your calculator, you actually get a value. You would get pi over 4, which would give you a value. They're real numbers. They're measurable. That's why we have to use radians. So on the left side, negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi. Now, this is moved up 3. So I'm going to draw in my new horizontal axis. And now everything I do is based on the new horizontal axis. Okay, so this is sine. So if this weren't moved, we would be starting at 0, 0. But now that it is moved, we're going to be at 0, 3. The amplitude is 4, so I know at my next angle I'm up 4. So in this case, I'm at pi over 4, 7. My next angle, I'm back to my axes. My next angle, I am 4 away from my axis, so I'm actually at negative 1. And my next angle, I'm back on my axes. And then coming over here, I am 4 away, so I'm down at negative 1 on my axes. 4 away, I'm at 7, back to my axes. Okay? So once you draw your new axis, you're finished with moving anything. This is based on the amplitude. Okay, so how do we describe this? Well, it's vertically stretched by 4. It's 4 times as tall, and it is horizontally shrunk. Now, I sketched in a parent graph. Again, I have people having issues with that sometimes. In the past, I have. But when I'm sketching the parent graph, I look for angles that I know. I know sine is 0 at 0, and I know at pi over 2 it's 1, and at pi it's 0. So you can see that I get half of a parent graph fits into one cycle. Okay, so again, what would be my domain? I can put in anything to my angles that I want. Okay, I could put in anything for x. I could put in angles here to see what values I get. My range would be everything from negative 1 to 7. Okay, so do I want you to describe, as I have, a horizontal shrink? A half of a parent graph fits into one cycle? Yes. All right, now let's take a look at tangent, our favorite trig function to graph. So y, in our next example is y equals negative 2 plus 3 tangent of x. So we're going to list out amplitude, which of course means a vertical stretch or shrink. We're going to list out period, which means a horizontal stretch or shrink. We're going to list out vertical translation. That is a translation, and of course if it was reflected, we would list that as well. Okay, technically for amplitude, amplitude's plus or minus infinity for tangent because there are not high points and low points. But we've seen from our parent graphs and our other graphs that it has a turning point or key points with A. So I will have key points plus or minus 3 away from my horizontal axes. My period is like the parent graph, it's pi. So just like whether it is tangent, cotangent, sine, cosine, or eventually secant and cosecant, to get my scale, I always take my period and divide by 4. So I'm going to be counting by 45s on this. This is going to be vertically translated down too. Now, Tangent is the only one that I graph a little bit differently in that I like two complete cycles. I don't like partial curves. So what I do first of all is I graph one cycle where I do half on the right side, half on the right side on the positive side, and then half on the left side on the negative side. Okay, so am I still going to count by pi's over 4? Yes, I'm going to go pi over 4, pi over 2, because 45, 90. Then I'm going to go negative pi over 4, negative pi over 2. I know that between here and here, isn't that a pi? Isn't this pi over 2 and pi over 2? So isn't that pi? So that's pi, that's the length of one period. So I know that at the beginning and ending, so to speak, of my period, I would have asymptotes because I got to know what's going on with tangent. At 0, oops, I forgot to say, I apologize, that first of all, this was moved down 2, so I'm going to draw a horizontal axis at y equals -2, and now everything I do is based on that horizontal axis. Okay, so one more time, this is between here and here is pi, and so I know that I have an asymptote at the beginning and ending of the period. And so I got to know what's happening with tangent at 0. If this were not translated down, it would be at 0, 0. But now this is my new horizontal axis, so I'm at 0, -2. And now these key points or turning points, you can see how the graph changes direction, would be 3 away from this. So if I'm 3 away, I'm at pi over 4, 1. And if I'm 3 away here, I'm at negative pi over 4, negative pi. These should be 3 away. All right, now continue. All right, I know that I have an asymptote here. I'm going to need 3 more angles and an asymptote to graph my tangent graph. It is the same approach. Whether you look at, if you look at this, you need 4 more angles to graph this. All right, same approach as we've always had. So I'm going to count by pi over 4. So 90 plus 45 is 135. That's 3 pi over 4. Plus 45 is 180, which is pi. 180 plus 45 is 225, which is 5 pi over 4. And then 225 plus 45 is 270, or 3 pi over 2. All right, so beginning, ending, that is pi. Think about it. If you go from pi over 2 to 3 pi over 2, that's pi. That's one period. All right, so 3 angles between, just what we need. Here's my point again, 0, -2. I'm up here at 1, and I am down here at -5. So one more time with tangent. I'm still going to write out my angles, and if you write out more angles than you need, that's fine. I mean, technically, we could do this another way. I'm going to show you this. If you don't like graphing on the positive side or the negative side, we could have started off this graph, and I could have continued down here, and I could have continued and made this, that's 3 pi over 2, so then I could have made this 7 pi over 4 and 2 pi. So if I didn't want to do this part, I could have just gone pi over 4 all the way to 2 pi, and then I would have had this part of the graph down here. So if you want to start at 0 and graph 2 cycles like we have with every other function, all right, you could do that. So sorry if that was off the camera. All right, so you could have gone from 0 to pi to get one cycle, and from pi to 2 pi to get the other cycle. That would give you 2 cycles. So your approach would be the same as any other function. You would take and count by pi's over 4s, and in this case you would get 2 cycles between 0 and 2 pi. Okay, so how does this compare to the parent graph? And again, keep in mind, we're graphing 2 cycles in our examples, as you do in the homework, as you do on the test. This is vertically stretched by 3, so it's 3 times as tall, moved down 2. Okay, let's do our last one here, sorry. Y equals 2 minus cotangent of 1/2 x. All right, so I'm going to list out my amplitude, period, x scale, vertical translation, and if it's reflected. So we know cotangent, technically the amplitude's plus or minus infinity because we don't have high points or low points in cotangent. However, we do know we have turning points or key points, and they would be plus or minus away from our middle point. All right, my period would be pi, this is cotangent, divided by half, so it's 2 pi. So my x scale will be 2 pi divided by 4, which is pi over 2. I'll be counting by 90s. This will be vertically translated up to, and this is reflected. So the fact that it is reflected means that cotangent is going to look like tangent, but we know that's not the case unless it's reflected. Okay, so how am I going to start this? Well, same with every other graph. Besides tangent, or if you want to do tangent the way I did here, that's fine. I'm going to graph part of it on one cycle on the positive side, one cycle on the negative side. All right, so my period is 2 pi. So I'm going to go count by 90s. These are my quadrantals. We should know these by now. Pi over 2 pi, 3 pi over 2, 2 pi. I'm going to come down here and go to the negative side. Negative pi over 2, negative pi. Negative 3 pi over 2, negative 2 pi. Now I'm moving up 2, so I have a new horizontal axis up 2. All right, now we got to know what's going on at 0 for cotangent. Cotangent is undefined at 0. So that means I have an asymptote here. We know that one cycle occurs between two asymptotes. So if my period is 2 pi, then at my other, at 2 pi, I will have an asymptote. And at negative 2 pi, I will have an asymptote. All right, so now knowing what's going on with cotangent, my middle angle, if this were not translated, would be at 0, but now it's moved up 2, so it's at 0, 2. My amplitude or key points are 1 away, so if this is 0, 2, or pi 2, this would be pi over 2, 1. This would be 3 pi over 2, 3. All right, that is one cycle, and then I just go to the other side and graph the same. All right, so I just erased my parent graph, or my explanation here, parent graph comparison. This is horizontally stretched, so I could fit 2 parent graphs. I don't want to draw that in with all the asymptotes and all that, but I could fit 2 parent graphs because the one parent graph I could fit between 0 and pi. So it's horizontally stretched, 2 parent graphs fit into one cycle, it's reflected, and it's moved up 2. All right, so the key to these is, first of all, with a vertical translation, draw in your new axis. Then everything is the same approach that you've done in the past with graphing sine, cosine, tangent, and cotangent. Take your period, divide by 4, that gives you your scale. And every time we do a graph, I'm going to ask you to graph 2 cycles. I do want to reiterate that this is 2 cycles, all right? In the past, because of what we've done in the parent graph, people will have twice as many of these. All right, this is 1 cycle because this repeats, so that is a 2nd cycle. Okay, know what goes on at 0. We know that sine is 0 at 0. We know cosine is 0a. We know tangent is 0 at 0. And we know cotangent is undefined, so there will be an asymptote there.